So we're going to look at this last section here, which is factoring completely. So we're not really going to look at any more strategies for factoring. We're just going to look at our previous three strategies, and then we're going to look at a mixed group of problems and see when do we apply what strategy. So we're going to kind of have a running list of what we should go through first to try to decide what's going on. So the very first thing we're always going to do is we're going to look for a GCF. So we're going to look to factor a GCF if we can, right? That's the first thing we're always going to look for. Do any of these terms, do they have a greatest common factor? If so, we're going to factor it out. And then we're going to do the next two things. And these really happen on the same level because we're going to have maybe one or the other. So maybe we stop at factoring a GCF, maybe we can't factor any further, but maybe we can. And currently we have two different kind of strategies for factoring further than just a GCF. So the first one is factoring a trinomial. So after you factor out the GCF, you're going to say, or maybe there wasn't one, you're going to look at what was in the parentheses or the original problem and say, is this of the form, x squared plus bx plus c, right? Is this a trinomial? And if it is, factor it. If it's not, we're going to ask ourselves the next question, which is going to be factoring a difference of squares. Factoring a difference of squares. So this is our a squared minus b squared situation. All right, so it's going to be one or the other, right? You can't be a trinomial and a difference of squares at the same time. So we're going to want to look for those. So we're just going to go through that list and factor. So again, no new strategies here. We're just applying all of them in different situations and determining what we need. So number one, I'm looking at these. I do not see a GCF. They don't have a greatest common factor between the numbers 1, 7, and 18, and they don't all share a common variable. So I'm going to go down my list of things to look at, and I'm going to say, well, this is a trinomial. So let's factor it. So trinomial factors, we're going to factor this into two binomials. We know to get our first term, x squared, we need to multiply an x times an x. And now we need to look at what two numbers multiply together. So multiply together to get negative 18, but add together to get a 7, negative 7. So we're going to think about the different factors of 18, and we're going to go ahead and factor that. So you don't always have to list out your factor pairs. That's just a strategy that can be helpful, but not always. So in this case, I'm looking at this and I'm saying, hey, negative 18 is negative 9 times 2, and if I add those, I get negative 7. So I'm going to go ahead and put those values in here. Okay, and we're done. Because I look at those and I say, oops, well, neither of them are a trinomial. Neither of them are a difference of two squares. So we're good to stop there. All right, continuing on. This next one also does not have a GCF, but it is a trinomial. So let's factor that. So we have a trinomial here. We're going to factor it into two binomials. To get an x squared, we multiply x times x. And I'm going to look at 14 and say what two numbers multiply out to 14 that add up to 9. And that would be a positive 2 and a positive 7. So again, if you want to write out your factor pairs of 14, go for it. That can help you out there. Okay, number 3. This does have a greatest common factor. This does have a GCF here. Okay, the GCF is 7 for the numbers. 7 and 49 are both divisible by 7. And they have an x in common, right? One has x squared, one has x. So you can think of this as having two x's and one x. So they have one x in common. So I'm going to factor that out. So when we factor a GCF out, we go ahead and divide both terms by that GCF. Okay, it becomes our distribution problem. And I'm left with x plus 7. Once we factor out a GCF, we always want to look at the inside of the parentheses and say, is that a factorable trinomial or is that a difference of two squares? It is not, so we know we are done. Okay, number 4. 4x squared minus 9. This does not have a GCF, but it is a difference of two squares. So remember, it's either going to, if it's factorable further, it's either going to be a trinomial or a difference of two squares. This one is a difference of two squares. So when we do that, we're going to say, all right, well, 4 is 2 times 2. X squared is x times x. And negative 9 is a positive 3 times a negative 3. All right, double check your parentheses. Can you factor them any further? The answer here is no. So let's keep going. Number 5. Number 5 does not have a GCF. So we want to go ahead and ask ourselves if it is a trinomial or a difference of two squares, a factorable trinomial or a difference of two squares. This is a factorable trinomial. So we want to look at how we can factor it. So this one, we want to maybe write out our factor pairs because 63 is not a number that we're often used to working with. So we want to multiply out to a positive 63, but add up to a negative 16. So that means both of our factors will need to be negative. So we would have negative 1 times negative 63. It's not even, so it is not going to be divisible by 2. So we just want to keep going on down the line. It is going to be divisible by 3. So we have negative 3 times negative 21. Keep going. Next thing is divisible by would be 7. So it's negative 7 times negative 9. And then that would be all of them. So if we're looking at checking to see if any of these pairs add up to negative 16, we have one right there, negative 7 and negative 9. So we can go ahead and write our two binomials. So we would have x minus 7, x minus 9. Okay. So next up here, again, this is a trinomial, but we want to check for a GCF first. So we always want to look for a GCF of the numbers and of the variables. But in this case, we only have a GCF for our numbers. They don't have any, they don't have a variable portion of the GCF. And in this case, the GCF is 4. So we're going to divide a 4 out. Remember, that does need to go in front because we always need to be able to work our way backwards. And we'll end up with an x squared minus 9x plus 14. Now we want to go with this inside and say, can we factor that further? Yes, we can. So let's do it. So we keep the 4, and this is a trinomial, so we're going to factor it into two binomials. Okay. So we're asking ourselves, what two numbers multiply out to 14 that add up to negative 9? Okay. Answer would be negative 7 and negative 2. So minus 7, minus 2. You can write out your factor pairs. So we're multiplying out to a positive number, but adding to a negative, so they both need to be negative. So negative 1 times negative 14, or negative 2 times negative 7, and we would see that factor pair right there. Okay. Again, we have a trinomial here, but we don't know if it's factorable yet, so let's try it out. So we want to look first for a greatest common factor. We have one. Our greatest common factor is going to be 3 here. No variable part, so our greatest common factor is 3. So let's factor that out. So we're dividing everything by 3. We're going to end up with an x squared minus 9x plus 8. All right, so now we want to try to factor that trinomial on the inside further. So we want to add up, multiply out to a positive 8, add up to a negative 9. This is one where it's kind of our most obvious factor pair, but we like to forget it a lot. So if we look at the factor pairs of 8, we're going to have negative 1 times negative 8, negative 2 times negative 4. These are kind of our options. And our factor pair is going to be this first one. So we made both of them negative because we need to add up to a negative 9. So if we have negative 1 and negative 8, those would add up to a negative 9. Okay, next problem, second to last. We're almost there. So we're looking at this. We do want to look for a GCF. There is not a GCF here for this one, but it is a difference of two perfect squares. So we can factor it that way. So two binomials. And remember, we're asking ourselves what are the square roots or what are the two things that we multiply together or the one thing that we multiply by itself to get back to our original value. So 16 is 4 times itself, or 4 times 4. X squared is x times itself, or x times x. 9 is 3 times 3, but we do want to end up with that difference, right, the subtraction. So we're going to have a positive 3 and a negative 3. And y squared is y times itself, or y times y. Okay, last one. We do have a greatest common factor here, GCF. Our GCF is 2. So we want to divide that out. So we have 2 times x squared minus 8x plus 15. And we want to try to factor this further. So we want two numbers that multiply out to a positive 15 that add up to a negative 8. So let's see if we can come up with some. And that would be negative 3 and negative 5. So just make sure you're always checking if you can go further. So after you do that GCF, just check if you can go further, and if you can, do so.